Yeah, okay. First of all, myself, Dinesh Kumar from Mechanical Department. I'm pursuing my final year BTech from SRIT, Anantapur. Today, my topic name is an overview of robotic sensing technologies. Okay, introduction to robotic sensing technologies. In robotic sensing technologies, enable robots to preserve and interpret their environmental. These sensors can critical enabling and autonomous operation and decision making. The field has seen rapid advancements, making the robots are more adaptable and intelligent. Here we can see that the robot arm is consist of these types of literature. It can be helpful for sensing technologies. The robots are not similar as humans, but the function is humans, but they don't have capability to sense and feel like humans. So in this we can discuss how the robots can feel the human interference, importance of sensing in robots. What is the major key and advantages of importance of the sensing? Sensing allows robots to gather real-time data about their surrounding. It can help to gather the real-time data, the current output data used by the robots, accurate sensor to improve navigation, object detection, and environmental understanding. Can be include the accurate object detection and environmental understanding. It will, for example, the robots are working in different environments. Based upon the environment and the condition, the robots working output will be changed. In these cases, we need to capable and understand and observe the what is the output capacity of the environment. It is rainy season or summer. Based upon the sensing and the input given to the robot, the robot function will be achieved, and enhanced sensing capabilities lead to safer and more efficient robotic systems. By giving good the exact input to the robots, these can lead to provide a best more chance to the robots and work efficiently rather than the other. Types of robotic sensors is also based upon the robot working capacity and environment. The types of sensors used in the robot can be changed. For example, proximity, force, vision, and environmental sensors. These are the basic sensors certain will be used in the robotic sensing purpose. For example, vision sensor, it will capture the forward the object which is detected by the sensors. It will capture and send to the robotic information technology. Each type serves specific functions essential for various robotic applications. Combining multiple sensor enhances overall system robustness and accuracy. For example, if we will include more type of different types of sensors in for robots, the input taken by the sensors will be capable to increase the performance of the robots. And for example, if any object will be detected by the sensor, it will take the information, and based upon the input, the robot will be working movement will be changed. For example, the environmental is changed into rainy season. In that cases, the robot want to work safely without the entrance of the water to the inside of the robots and its components. Proximity sensors, it is one of the basic sensors. Proximity sensors detect the presence of object without physical contact. Common types includes infrared and these are similar sensor we can observe here. Sensor is detected, it is proximity sensor. There is no physical contact between the sensors and the robot. Based upon the sensing technology, it will capture and sense the object. For example, based by using infrared and ultrasonic and capacitive sensors, the robot function will be changed. These rays will be penetrate into the object and detect the object length and dimensions of the object. They are widely used for upscale avoidance and collision prevention. These are used for wide scale due to collision and avoidance. For example, without sensing, the all types of equipment will come under. miscommunication and mislead. It can lead to discommunication purpose. It is probably used in a large scale of industries. Ultrasonic sensor, it is one of the most common sensor. Ultrasonic sensor used to sound waves to measure distance of one object. They are cost effective and suitable for detecting objects in various environments. These will sends the ultrasonic waves to the object. If the object will be observed and returned back, it will says that there is one presence of an object. If the ultrasonic waves will be pass out to the object, it can say that there is no presence of an object. The cost is effective and suitable for all environment, detecting various environment. Their limitations include sensitivity to environmental noise and surface properties. Based upon the environmental and surface properties, ultrasonic sensors utilization and applications will be changed. Infrared sensor is going to infrared sensors detect the objects using emitted or reflected infrared light. They are often used to object detection. The following, for example, when the read is present and returned back to the base, that means the object is present in that case. When it is emitted back, and then it will be said that they are often used by object detection in the following problem. Infrared sensors can be affected by the ambient light and surface reflectivity. Based upon the ambient and surface reflectivity, in this picture we can observe that one will take the sensor will be emitted and the one another sensor will be take the capture the return back of the sensor waves. In this ways the sensor will be work. Another type of sensor is force and tactile sensor. Force sensor measure for the amount of force pressure applied on the sensor. These sensor will be capable to understand how much of pressure is applied on the surface of the object. Tactile sensor or enable robots to perform tactile manipulations. These sensors are crucial in applications requiring precise force control. Force control is tactile sensor. These will be plays a crucial role for applications. Tactile sensors or robots perform a duplicate manipulation. For example, we want to do and test on a certain type of material. In that case, the robot's force sensor will detect the how much force will be executing on the material of the raw material. It will lead to capture the load carried by the material. So vision sensor in robotics. Vision sensor includes cameras and images processing system. Vision sensor these will use the mini cameras and image processing systems based upon the input recorded by the cameras. It will capture and processes the image and then will send to the next stage. They provide detailed visual information about the environmental. These will capture the surrounding environmental procedure and timings. Based upon the input, the next stage will be processed. Vision sensors are essential for tasks like object recognition and navigation. For example, we can use GPS and another types of robotic traveling system from one place to another place. In this situation, we need then cameras on practical navigation location tracking cameras. In this case, these will capture the location and traveling distance time and then it will forward to the next step. Types of vision sensor is also cameras can be monochrome or color with varying resolutions. Nowadays, we can observe the different types of resolution cameras. Based upon the robot application and implement, we can implement the type of sensor based upon the resolutions output like 4K, 8K recordings, etc. Depth cameras and LiDAR provide three-dimensional environmental data. Based upon the three-dimensional views and the camera's point will be changed. Advanced vision and sensors enable complex tasks like facial recognition and mapping. These can lead to develop the different types of facial recognition and mapping technologies. These can lead to provide the more useful output. Light detection and ranking sensors. This is one type of sensor. LiDAR sensor emit the laser pulses to measure the distance and generate the 3D maps. In this picture, we can observe the robot near the sensor. It will emptying the rays on the presented underscore the object. These are in a 3D shape. The laser measures the distance between the object and the position of the camera view. These are widely used in autonomous vehicles and outdoor robotics. The outdoor robotics will continuously work from one place to another place. These will used for autonomously vehicles, and LiDAR offers high accuracy but can be affected by weather conditions. The LiDAR is one of the accuracy available. These can be affected by the weather condition. It will not be suitable for weather application. It will be differ from one place to another place on conditions. And next one's radar sensors in robotics. Radar sensors, these will scan the certain distance location up to certain time. Radar sensors use radio waves to detect objectives and measure the speed. These sensors, for example, in highways, the sensors will be used by the robots. These will capture the speed of the vehicle, and sometimes the capture by using robot sensing technologies. And they perform well in adverse weather and low light conditions. Based upon the low light conditions also, by using red light indications, these can be also work then it will be give the best output. Radar is commonly used in autonomous driving and aerial robots. The radar is commonly used in autonomous driving vehicles. So for example, large scale of industries, these will be provide an automatic guided vehicles. In that case, we need the radar communication system. When we implement a radar communication system, in that case, it will be more practically the robot working capacity and efficiency of the robot will be increased. Environmental sensors monitors parameters like temperature, humidity, air quality. These will measure the outside temperature based upon the seasonal weather. The temperature and the humidity will be changed. In that case, we need to sensor to capture and measure the output temperature and capacity of the humidity water vapor present in the surroundings. They help robot to adapt their behavior based upon the environmental condition. Some robots are designed for only certain types of environmental sectors. In that case, we don't have chance to control the environmental. So when we implement the environmental sensors in robot sensing technology, the robots will automatically adapted to their temperatures, and it is capable to work efficiently from the output of the robot. Such sensors are visual in applications like agriculture and environmental monitoring system. These are the two stages we can use the environmental sensors in such case of agriculture and environmental monitoring. Sensors fusion in robotics. Sensors fusion combines data from multiple sensors to improve accuracy. Sensor fusion, it is also common as a sensor sensing capability of data. In for example, in every robot, it will consist of different types of sensors like environmental sensors, sensing visualizing sensors based upon the input taken by the different types of sensors, and it will combines the data from the different types of sensors. It helps to mitigate individual sensor limitations and continuities. It helps to the development of based upon the inputs given by the all type of sensors. We can easy to capable the work the to get an efficient output. Techniques include Kalman filtering and Bayesian approaches. These are the one type of fusion robotic sensors. Challenges in robotic sensing. The major challenges were faced by the robot sensing is also sensor noise and increases can affect precision quality. For example, sensors utilized in heavy noise pollution areas. In that cases, the sensors will be produce more noise, and there will be minimal error occurrence of sensor quality, and there is a minimal chances to get the errors from the sensors input. Environmental factors can interference with sensor performance. For example, sudden thunderstorms or due to heavy rains, this can lead to miscommunication. Taking the input from the sensor, it can lead to the change the minimal errors. Designing sensors that are reliable, designing effective and energy efficient remains a challenge. These can produce an energy efficient remains challenge. It can be one of the most challenging according in robotic sensing technology. Yeah, recent advancements in robotic sensing technology is also development of lightweight, high resolution sensors enhance mobility. Nowadays, the researchers will be working on the robotic sensing technology will play a crucial role for robotic sensing purpose. Developing of lightweight sensors will be decrease the weight of the robot and easy to movement purpose. High resolution sensors, these can increase the mobility and try to get the capable of best resolution output from the robot. Machine learning algorithms improve interpretation of sensor data by based upon the given input coded by the coders to the interpretation of sensor data. The output will be performed. Integration of sensors with cloud computing enables the real-time data analysis. These by using cloud computing, these can enables the real-time data analysis. Applications of robotic in sensing technology. So robot sensing technology at autonomous vehicles manufacturing on healthcare, these can be applicable. Supports exploration in hardships on incredible environmentals. Sensing technology is also available human robot interface and safety. Future trends in robot sensing technology goes to miniaturization will be lead to more compact and under precision sensors. Integration of multiple spectral and miscellaneous system enhance the precision. By implementing these types of sensors, we can increase the precision output by the robots. Emerging AI driving processing will enable to more autonomous decision making. If we can implement the AI driven processing in the in the automatic robotic system, these can lead to analyze the robot, the current situation, and based upon the situation, the robotic will be perform their individual actions. Ethical and safety consideration is also accuracy sensing is crucial for ensuring safety in human robot interactions. Privacy concerns arise with vision and environmental sensors collecting data. Developing standards and regulations is essential for responsible development. Accuracy sensing it plays a crucial role for the robot output. Privacy concerns arise the vision and environmental sensors collecting the data. The vision and environmental sensors collect the data. These can lead to the more important output for the robot. Efficient. These can also increase the efficiency of the robot. Conclusion. Finally, I can conclude that robot sensing technologies are fundamental, advancing autonomous systems. Continuous innovation is expanding the capability and applications of robots. We want to improve the robotic sensing technologies. Continuous improvement can lead to change the rapid world. Today's world will be revolve around the AI and the robots. If we can combine the both AI plus robot, the world will be changed. Addressing current challenges will pave the way for more intelligent and reliable robots. By implementing the AI with the robots, we can get the more efficient work from the robots rather than the manual work by the humans. Finally, thank you for giving this opportunity. Thank you.